Today we'll discuss the use of MAR and MDR in memory access. But before we do that, let's talk about what MAR actually is. So memory address registers or MARs are an important component of the modern computer systems. They are a type of hardware register that holds the memory address of the data that needs to be accessed or retrieved from the memory. The purpose of a MAR is to communicate with the memory unit and let it know which location in the memory needs to be accessed. The MAR works in conjunction with the memory data register, MDR, which we'll look later, which holds the actual data that is being retrieved from or written to the memory. When a program running on a computer system needs to access a piece of data that is stored in the memory, it first sends a request to the memory controller with the address of the memory location where the data is stored. The memory controller then retrieves the data from the specified location and stores it in the MDR. Once the data is in the MDR, it can then be transferred to the CPU or any other destination as needed. This process of loading the MAR, accessing data from the memory and storing it in the MDR is called a read operation, which we'll look at in detail later. MARs are typically designed to be as fast as possible so that they can keep up with the speed of the CPU. They are also often optimized for certain types of memory access patterns, such as sequential or random access. In conclusion, memory address registers or MARs play a crucial role in the memory access process of modern computer systems. By holding the memory address of the data that needs to be accessed, the MAR allows the memory unit to quickly retrieve the requested data and transfer it to the CPU or other destinations.
Hello everyone, this is Riddhi Bhandare. I will talk about the MDR. MDR stands for Memory Data Register, which is a special register in a computer CPU, that is, the central processing unit, that stores the data that is being transferred to or from the main memory. The role of MDR in memory access is to act as an interface between the CPU and the main memory. When the CPU needs to read data from the main memory or write data to the main memory, it uses the MDR to transfer the data. When the CPU wants to read data from memory, it sends a memory address to the memory unit. The memory unit uses this address to locate the memory location where the data is stored and transfers the data to the MDR. The CPU then reads the data from the MDR and performs the necessary operations on it. Similarly, when the CPU wants to write data to memory, it sends the data to the MDR. The MDR holds the data until the memory unit is ready to receive it. The memory unit then stores the data in memory location specified by the address sent by the CPU. In summary, the MDR is a critical component in a memory access process. It provides a temporary storage location for data being transferred between the CPU and the main memory, enabling the CPU to access the data it needs to execute instruction and compute computation.
Write operation in memory. The CPU sends a request to write a word of data to a specific memory location. When a program running on the CPU needs to write a word of data to a specific memory location, it sends a request to the memory subsystem. The request typically includes the data to be written and the address of the memory location where the data is to be written. The address is typically stored in the memory address register, also known as MAR. In computer systems, a word typically refers to a fixed size unit of data that can be processed by the CPU or stored in the memory as a single entity. The size of a word can vary depending on the architecture of the computer system, but it is typically 2, 4 or 8 bytes in size. A word of data refers to a fixed size unit of data that is typically used in computer systems. This can include a number, a character, or any other type of data that can be represented using binary digits or bits. For example, a 32-bit word of data might represent a signed or unsigned integer, while a 64-bit word of data might represent a floating point number. the memory subsystem prepares to receive the data. Once the memory subsystem receives the write request, it prepares to receive the data. This involves setting up the appropriate memory chips and registers to receive the data. The address stored in the MAR is used to identify the specific memory location where the data should be written. The word of data is written to specified memory location. After the memory subsystem is prepared to receive the data, the word of data is written to the specified memory location. The data is typically stored in the memory data register MDR, which is a register that holds the data before it is to be written. The data is then transferred from the MDR to the specified memory location, which is identified by the address stored in the MAR. The CPU is notified that the write operation is complete. Once the word of data has been successfully written to a memory, the word subsystem signals the CPU that the write operation is complete. The CPU can then continue executing the program or read the data back from the memory if needed.
Hello guys, in this part we will see how computers read data from memory. The first step is the CPU issues a read command. In this step, the CPU sends a command to the memory controller requesting to read data from a specific memory location. This command includes the memory address of the location, which is like the street address of a house. In step 2, the memory controller locates the requested memory cell. The memory controller receives the read command and decodes the memory address to find the corresponding memory cell. This is like finding the house that matches a given street address. In next step, the requested data is transferred to the MDR. Once the memory cell is located, the data it holds is transferred to the memory data register, that is MDR, which is a special register that acts as an interface between CPU and memory system. Think of MDR as a temporary storage area for the data that is being read from the memory. And in last step, the data is transferred from the MDR to the CPU. Finally, the data in the MDR is transferred to the CPU, which can now use it in its computations or store it in another memory location. This is like carrying the package from the house to the recipient's hands. And that's how the read operation of memory works. It's a crucial part of any computer system, and it allows the CPU to retrieve data from memory and use it in its calculations. Keep in mind that the read operation can take several clock cycles to complete depending on the speed of memory and the system bus. I hope you found this part informative and helpful in understanding how computer system works.
So, in conclusion, we can say the memory address register, that is MAR, and memory data register, that is MDR, are critical components in the memory access process. The MAR is responsible for holding the memory address of data that needs to be accessed, while the MDR holds the actual data that is being retrieved or stored. By understanding how these registers work together, we can better understand the mechanics of memory access in computer systems. Whether we are performing a read or write operation, the MAR and MDR play important roles in ensuring that the data is accessed accurately and efficiently. Additionally, as we continue to develop more advanced computer systems, it will be important to consider how these registers are implemented and how they interact with other components of the system, such as virtual memory and caching. Overall, the use of MAR and MDR highlights the intricate nature of computer systems and the importance of understanding how individual components work together to achieve a larger goal. As technology continues to evolve, it will be interesting to see how these registers continue to play a role in memory access and other processes. Thank you.